Okay, in order to graph a hyperbola, the standard form is x squared over a squared minus y squared over b squared equals 1. So similar to the ellipse, but a subtraction sign instead. The rest of it goes the same way. Is this in standard form? Yes. What's the center? In other words, the HK. In this case, it's easy. It's 0, 0. Go down here to number 3. What's the center here? 3, negative 1. Good. And number 2 is also super easy, 0, 0. Please be quiet, guys. All right. In order to find the vertices, let's find A and B. What's A? Yep. So A squared is equal to this thing under X, 4. So that means A is equal to 2. B squared is the thing under Y. That's 25, which means B is equal to 5. Now, I'm going to plot the center, 0, 0. And since A is under X, I'm going to go horizontally from the center point, 2 units right and 2 units left. And I'm just going to put little dots there for a second. Those are called my vertices. Bless you. And then for the Y directional, I'm looking for what's under the Y. 25 square root is 5. So I'm going to go up and down 5 units. 1, 2, 3, 4, 5 from that center. 1, 2, 3, 4, 5. And whereas in an ellipse, I would connect those and make my elliptical shape, this time we're going to do it differently. We're going to make a box. Make a box that goes through all 4 of those vertices and co-vertices. And the vertex in this case is going to be 2, 0, and negative 2, 0. And the co-vertices will be 0, 5, and 0, negative 5. Remember that to find the focus, we're looking for the C. And whether it's an ellipse or a hyperbola, our equation for finding C is different. In this case, it's C squared is equal to A squared plus B squared. For an ellipse, it was A squared minus B squared. So we'll say C squared is equal to 4 plus 25. So C squared is equal to 29. So C is equal to root 29. And just off the top of your head, if you had to estimate this value, what's this approximately equal to? 5 point something. Do you agree? The square root of 25 would be 5. So it's more than that. So notice what's going to happen. Even if this were where the focus was going, because this is the transverse axis, it would be outside of the box, wouldn't it? Which is what's going to make it a hyperbola. It's going to be outside of the box. In this particular case, because we're going left and right, this is x squared first. So it looks like an x. So we're going to go from here, right, root 29, 1, 2, 3, 4, 5, and a little bit. And that focal will be root 29, 0. And if I go left, 1, 2, 3, 4, negative 5, and a little bit more just to graph it, that's going to be negative root 29, 0. And I'm going to make my little hyperbolic shapes here, but it's hard for me to tell what it looks like, how steep it is. So I'm going to use the corners of my box that I've created. And if I put dots on the corners, they'll make a collinear line through the center. And that's an asymptote for me. I'm going to draw a little dotted line. And then I'll do the same going the other way. And then you just follow it. We know that our vertex starts here because it's got X first. It's going to look like one of these. So I'm just going to go like that, and like that, and like that, and like that. And these are my focal points here. They're inside that hyperbolic shape. Now, the equation of the asymptote is going to be y is equal to, let's leave this alone for just a second. And then it's going to be x minus, in this case, my center is 0, plus my y value is 0. What's my slope of this? Well, it's going to be b over a, isn't it? Because this is my b, and this is my a. So my rise is up b units, and my run is over a units. So it'll be 5 over 2. And we'll have one that's positive and one that's negative. Yes. Graphing this part? Yeah. So step one is decide whether it looks like this or like in this one, because the y is first, it goes y squared minus x squared. This one's going to look like that. Because of that, you know that this is called your transverse axis. In other words, these are your real vertices, and these are just like your faux vertices, your co-vertices. And so I plot those vertical points. Those are the vertices that start my shape. And I'm just going to use my asymptotes here. I come from this vertex out along the asymptote. It's a really rough sketch. Yep. Okay, let's come down to this one. The only difference here is that it's a Y shape, right? And because we did that, what's our A value going to be? And our B value, B squared is 9, so B is equal to 3. And this time, bless you, because Y is first, I know that I'm going to have my shape look like this, which means the vertices are going to be the ones where I'm adding on the A in my Y direction. So I'll have 0, 6 going up, 6, and 0, -6 going down. Just like we did in an ellipse, because the thing under Y is a 6 squared, I'm going up and down 6. And because the thing under the X squared is 9, how much am I going left and right from the center? 3. 1, 2, 3, 1, 2, 3. And these are helpful. This builds my box, right? I need that box. Let you guys catch up for a second. How do I know which of these is vertices and which ones are co-vertices? Is it the same or different than the way we did it with ellipses? It's different. In an ellipse, I choose the long one, right? In an ellipse, these ones would be called my vertices because they're part of the long axis, the transverse axis. In this case, no, I see your point. Yeah, it does work as well. It's the same as an ellipse this time, because since the y squared was first, y squared minus x squared, it's going to be one of these shapes. So it is going to have that vertical transverse axis. So I did this. Yeah, this is right. And then this would be 3, 0 and -3, 0. How do I find my foci? I need my C. For a hyperbola, C squared is equal to A squared plus B squared. So C squared is equal to 36 plus 9. C squared is equal to 45. So C is equal to root 45. And we can simplify that to 3 root 5 if we want. Makes it better for showing the foci. Will those go left and right along the x-axis, or will they go up and down along the y-axis? Good, up and down, because it's one of these. I want my foci to be outside the little curve shape. So my x value is still going to be 0. My y value is now going to be 3 root 5. And this one is going to be 0, negative 3 root 5. And when I estimate that, square root of 45 is somewhere between 36 and 49, so somewhere between 6 and 7. So I'm going to go up 1, 2, 3, 4, 5, 6. It's going to be just outside here. 2 foci. These are the exact points, but I need to graph them. And now I'm going to draw my asymptotes. Connect the corners of my box. Once I get that, where do I draw my curves? Up here, right? So I come from this primary vertex, not a covertex. And again, I should expect that the foci are cupped within the hyperbolic shape. And what are the equations of the asymptotes? Y equals plus or minus, what's our slope for this one? Up 6 over 2 over 3, which makes it just 2. And because it goes through 0, 0, we can just call it plus or minus 2x. Okay, so again, your homework tonight is to review logs and exponents in preparation for the test on Thursday. You will not get notes. You will not get a partner this time. And I've only got one more question for you to do on hyperbolas. We'll work more next class on that. Thank you.